Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper from the Hugging Face trending list, published on September 4th, 2025, about 3 days ago. The standout idea is a zero-shot system that embeds entity mentions and open-ended type descriptions into one space, delivering strong retrieval without a fixed schema and outperforming lexical and dense sentence baselines. The paper is titled NER Retriever, Zero-Shot Named Entity Retrieval with Type-Aware Embeddings. And as we'll see later, the implications for scalable, schema-free search are quite significant. In short, mid-layer value vectors plus a lightweight contrastive projector yield compact, type-aware embeddings that enable practical nearest neighbor entity retrieval. Also, the authors shared an official GitHub repo. You will find a clear README, MIT license, and a runnable demo of the full pipeline. It includes entity detection on FewNerd, indexing with LLaMA 3.1 plus a contrastive head, and retrieval scripts. Utilities, pre-trained weights, configs, and requirements are included. Figure 1 illustrates how the system turns open-ended type queries into entity-focused retrieval. The figure shows 3 stages that map messy text into a clustered space, then return passages that mention entities matching a natural language type. Ad-hoc named entity retrieval means the user supplies a type description at query time, which the system embeds alongside entity mentions. The example uses dinosaur to show indexing, clustering, and final retrieval results. Alright, figure 2 shows the end-to-end retrieval flow, which turns entity spans and a natural language type into compact vectors that can be matched by similarity. The frozen large language model yields a mid-layer value vector, which means the self-attention value output that carries token-specific content. A small multi-layer perceptron projects both mentions and the type into a shared space, so indexing stores entity vectors and querying retrieves nearest neighbors. So Table 1 pinpoints where type signals are strongest across models, which matters, because retrieval quality depends on the chosen internal representation. The table shows that LLaMA 3.18b wins with Block 17 value vectors scoring an AUC of about 0.78. T511b's encoder input normalization follows closely, while Gemma 27b and Mistral 7b trail. This ranking supports selecting mid-layer self-attention value outputs for embeddings. So Table 2 summarizes how well each method retrieves the right entity mentions, using R precision, which scores how many correct items appear within the right cutoff. The table shows NER Retriever leading on few NERD and multi-county NER2, while tying the best baseline on the NE Retrieve test. The Oracle span variant scores higher, which signals that span detection limits overall performance. These results matter because type-aware embeddings handle short, low-context text better than sentence encoders. Okay, 2 takeaways stand out. Mid-layer value vectors carry the strongest fine-grained type signals, and a tiny contrastive projector turns them into compact, type-aware embeddings that beat sentence encoders for zero-shot entity retrieval. The broader implication is schema-free, storage-efficient search over messy text at scale. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.